Hi, this is the second part of section 5.4 in discrete mathematics. We're going to introduce how to find sequences with their generating functions. In example 1, f of x equals to 1 over 1 minus x squared. If you compare it with this first identity, the only difference is we have x here in the identity but x squared for the given function. Therefore, I'm going to write down f of x in its expanded form by substituting x squared as a quantity here for x. There we have f of x, which is this function, equals to 1 plus quantity x squared plus quantity x squared being squared. In general, that's going to be the quantity x squared to the power of n. Okay, please note that we do omit some terms here in between and terms afterwards. Okay, but they do exist. We can do a little simplification to the powers to see that there are really just only even powers for terms of x. Indeed, if you want to insert all the odd powers, you can do that by multiplying each term with a 0, right? 0 times x is actually just 0, so we didn't change the value of it. But with this version, you will see that an, as for the sequence, can be found as 1, 0, 1, 0, 1, and so on. So that's the sequence an by definition of generating functions. If you want to write that out as a nice form, as a uniform form, you can say an equals to 0 or 1. It is 0 for odd indices. It is 1 for even indices. Okay, let's play the same game to example 2. First of all, f of x is given as x over 1 plus 5x. Now I can rewrite that by factoring out x and rewriting the positive sign by double negation. So 1 plus 5x is rewritten into the equivalent expression 1 minus quantity negative 5x. To use the identity, I'm going to substitute negative 5x as a quantity here as the x in our identity. Therefore, I'm going to copy down that x in front and rewrite this rational function in my next step. That makes it x in front times the sum of the following terms by, again, replacing each x by quantity negative 5x. And that is important because you definitely don't want to put that square inside of the parentheses. You want to view this as the square of the entire quantity, which makes it negative 5 squared times x squared. Okay, and we apply that to each term here. Now let's distribute this factor x inside of the bracket, meaning I'm going to multiply this x to each term, and then we will have x times 1 gives us x, x times negative 5x gives us negative 5x squared, and so on. Now if you pull out all the coefficients, we see coefficients list 0, 1, negative 5 squared, and so on. Which means we can write an in the form of, you want to try that? You may want to pause this video here and try it on your own to write an as in terms of n, okay? And continue this video when you're ready. Okay? Indeed, we can write an as, if you observe this sequence, you can write an as negative 5 to the power of n minus 1 for all indices n greater than or equal to 1, and an is equal to 0 when the index n equals to 0.